Hi, this is Chris and Jakub from Pagepro, and today Jakub is going to share with us 3 ways to optimize Next.js costs on Vercel. So Jakub, thanks for sharing your knowledge about Vercel and Next.js optimizations. Please start with, please name the 3 options that you're going to show, and let's start.
Hi, everyone. So I will talk about 3 solutions. The first one will be choosing the correct rendering method, which is the most important one. Second one will be about prefetching. And the third one will be about function options that you can change to reduce your costs. So that will be the top 3.
Perfect. So those items are very, very interesting, and there's just 3, but we're going to share more of them on our upcoming webinar next week. So if you're curious, please use the link from the comments and sign up for the event. Jakub, please start with first way.
Okay, so as I mentioned, there will be choosing the correct rendering method is the most important thing, because if you are choosing the server-side generation in places where your content is not updating too much, you are using a lot of resources on Vercel, like function execution and function invocations, which is the metric that is used in your billing. So this is the most important, because you need to reduce the amount of resources that you will need. And if you will use static site generation or even static content, which will build your page once, and then you can revalidate that using some revalidation methods, that can save you a lot of resources. So maybe I will jump into the code so I can show you some examples of how.
Jakub, can you also tell us how we can identify which pages can be statically generated and when do we need server rendering?
Yeah, that will be my first point. So just let me know if you can see my screen.
Yes, I can see your screen.
Yeah. So to identify which pages are rendered in which way, if you run yarn build or npm build or pnpm build, depends which tool you're using, it will create you some output that will tell you about pages that were generated. As you can see, they are listed here.
Jakub,
you also
can
get
you
some
make this text a bit larger? Is it possible?
Yeah.
Oh, great. Thanks.
This one. Is it readable?
Yes, looks good.
Okay, so as you can see in my example, I've got 4 pages, those ones, and you have a legend at the bottom. So the empty circle means that it's a static pre-rendered page, so it will be rendered once. F means that it's a dynamic server-rendered function, so each request will execute your code and re-render your page. And I don't have a sample of the static site generated page, but I will show you after my updates. So this is how the basic output looks like. Let me run this project so I'll show you that it's a very simple app, but I will So it's this application. It's very simple, but let's say that I need this information on every request. It's my homepage that will be like dynamically fetched, because every user have different locations. So I want to grid them based on location, and I want to do that on the server instead of the client, because I can. But in your application, it will be more complex scenario. So I have a post lists, and I have the post details pages. So if I click here, as you can see, this page is not changing too often. So I can easily rewrite that. So it will be generated once. And then if the content will change, I can revalidate that. So if we go back to code, I'm not sure if you are using any AI tools, but I will show you some, I hope, cool sample of how you can use that. I'm using Cursor.
Sure.
So in my scenario, I will go into blog page, which is the dynamic parameter, which have dynamic parameter, and it's rendered based on the parameter that you are passed here. So as you see, there's no extra code related to any generation, and that's why it's a dynamic function. But if you want to make this a static one, I can just ask Cursor to do that for me. So let's update this page to be static. And it should give me some code sample how to do that. It doesn't have to be perfect, but it's just creating a boilerplate for me, and I will update the body inside of it. So if we have this generated content, as you can see, I'm only missing the import. And in my scenario, it actually looks okay. So I'm just fetching all of the posts, and then I'm just generating those IDs. So we can have the list of IDs on the build time, and that's how Next.js will be able to build my pages during the build. I also adding this parameter to make sure that we are forcing these pages to be static. We can also add a revalidate parameter, as I mentioned, but that's only if you want to have a time-based revalidation. So your pages will be rendered once per this duration. So let's check if it works. And we should have this icon with F should be changed to full circle, but let's see how it works. Should be a quick one. And yeah, as you can see, this page is now marked as SSG, which means that it's pre-rendered as static HTML, and we have the list of URLs that are generated. It's a good pattern to match this with ISR, which is the incremental static regeneration. And if you're using, for example, a CMS or a source of data that you can attach, for example, webhook, you can create a webhook that will be triggered on every update or, for example, creation of the new post or new data. And you just need to create, I don't have it in this example, but you need to create an API route that will trigger the revalidation method for specific path. And next time when user visits this page, it should be up to date. So thanks to this optimization, we save like the X amount of requests that will be triggered, because now we build this page once during the build. So each build will generate those pages. And then when user visits them, they are already served as HTML. So we don't waste resources on building these pages because they doesn't use any dynamic data. In the page, I have this dynamic catch-all, but I want to leave it because, as you saw, there's a homepage and it has a welcome message which uses the location data, and I want it to be dynamic, so it will be always up to date.
Okay, so the whole application was using server-side rendering, and now blog posts are using static generation, right?
No, not all, because the page is like not found, and the blog listing page were the static generated, and they remain the same. Okay. I've just changed the blog details pages. They were previously using SSR, but now they are using SSG.
Okay, so now the tricky question: how much did our Vercel bill dropped after this switch?
It depends on our traffic and how much this function, how long this function was executed for. So, for example, if we are fetching, I will try to do this here. So, if we are fetching like two sources for data. So, and each of them takes like 200 milliseconds. Then our function execution will be like 400 milliseconds plus some extra time for other actions. Let's say that it will be like 50 milliseconds. So now, instead of calling these 450 milliseconds on each request, so if we have like 1,000 of users per daily, then we are using like 1,000 multiplied by 450 milliseconds. It's calculated here. So we are using like 7.5 minutes of execution time, but we are also using like 1,000 of invocations of our functions. If we go for SSG, then we have these numbers reduced to a single one because we are now increasing the build time, but we are reducing the later time when user needs to fetch the page, get these details, etc.
Okay.
This number
Great.
probably will be a little bit lower because if we'll use some cache or something, we can reduce these numbers too. But yeah, in very simple scenario, let's say that we saved like 7.5 minutes per day of the execution.
Okay. Okay. Cool. Great. So, as I understand, this is one of the biggest biggest changes that we can make. So, if we want to optimize the spending, we need to check how pages are rendered, and I guess also switching from SSR to SSG also is boosting our performance, right?
Yeah, it should, because now we don't need to wait until the request is done to get the page data, and it's immediately fetched as HTML. So yeah.
Okay.
But yeah, this is like the thing that is very much related with our application requirements. So it's the hardest one to implement in a lot of scenarios, and also the implementing the ISR, which is probably necessary in most scenarios, will also like add a development time that needs to be calculated too. So
Okay.
let's say that you will spend like 2 days on adding incremental revalidation. Then you need to calculate how much of the saving you will get thanks to this. So is it worth or not?
Okay. Great. Okay, so what is the next optimization we can have?
Yeah, the next one is not that big. It's very like not too many people use that. It's about prefetching, because by default in Next.js we have a prefetch enabled, and it's prefetching the page's data when the links appear on the screen. So if we have any links to our application on the screen, Next.js triggers the prefetching of the data for these pages, so they will load faster. But in a lot of scenario, this event is not triggered. I mean, a lot of users is not visiting all of the pages; they're just visiting the specific ones. But on the every page, let's go to my example. We have the navigation, let's say, and this navigation have like 1, 2, 3, 4, 5 URLs. So each refresh of this page, I mean, every entry on this page will prefetch all of those URLs, which is probably not a big deal. But if your page props are big, then those requests can be like let's say 1 kilobyte per URL. Then you have like 1, 2, 3, 4, 5, let's say 6, 7, around 10 URLs that are prefetched, and also those ones. So like 15 URLs on this simple page. So if you have a complex page, I bet that there will be like 20, 30, 50 URLs that will be prefetched. It's only the page data, so it's not a big deal. But even if that will be a half of kilobyte, you're doing that for every URL on the page. So it may be trivial, but on the bigger scale, it's worth it because it's a very simple fix.
Yes.
You just need to go to your
Yeah.
header.
You're saying that by default, Next.js is having this prefetch mode enabled, right? And when it happened, it's happening. This prefetch is happening on the page refresh, or just on the visible elements, or when the user is scrolling, then the prefetch happens when something is on the screen.
So in page router, you can specify 3 options. It will be by default. It's when the elements appear on the screen when they are in the viewport. That's the default one, and it's the default for both of them, for app router and page router. And and they are just prefetched when they appear on the screen, or with a little threshold, so a little bit earlier. But yeah, they are prefetched on when they are close to the viewport. So that's the default. You can turn that off, and in the page router, it means that they will be prefetched on hover. So if you mouse over them, and in the app router, there is a different functionality which is blocking the prefetch at all. So they work a little bit different, depends on the router that you will use.
Cool. So we don't have just 2 ways of optimizing, turn on or turn off, but we also can optimize by changing the settings.
Yeah, but it depends on the router which we will use. But to simplify that, you can just create a component like I do, which will be like link no prefetch, which will take basic parameters here, basic props, but you can pass anything you want here. And you can either add a prefetch false in app router, which will disable the prefetching at all, or you can use some workarounds like I did, which will trigger the prefetch on hover. So I just created a method that is calling an Next API to prefetch specific URL, which is the URL for my link. So you have you have multiple solutions here, and if you go to this, you can then specify manually which links will have the prefetch and which ones will not. So in my scenario, like this blog site is not having a prefetch, but the homepage does. So it's not like you need to turn that on or off globally, but you can specify that for specific scenarios. So if you think like a user, just think on your top paths that you are visited and just leave the prefetch on those top paths enabled, and just disable it for the pages that are not visited often. But yeah, just keep in mind that it's not something that will save you a lot of money, but it can reduce the bills by small amounts.
Cool. Yeah, very good. So we have the last optimization. How it's called? What we're going to do?
I just named that the function options because in Vercel you can change the default specification of your functions, which is like 1 minute of time and can save you a lot of time. I will start with showing you how to do that with Vercel dashboard. So if you go to your project and you go to settings tab, which is at the end, then you go to functions, and now you can scroll down a little and you have the function max duration. This setting controls, like as you see on the screen, you can specify the maximum amount of time that the function can be executed. And in general, it's just a thing that will help you if you have a code that is incorrect, like if you have a recurrence or something that is keep calling itself, and it's like keep extending your function duration instead of taking like 1 second of time. It just takes all of the time that it's assigned to this function, and it's just timing out after that time. So you want to specify this max duration to the minimum amount to eliminate the risk of having such functions, because even a single function can increase your bill by a lot, because if it will be called like 1000 times per day, and instead of taking 1 second of time, it will take 15 seconds of time every time, then your function execution will go up by a lot. You can set a similar thing for CPU and RAM allocation, but like the max duration may bring you some benefits if you have like the scenarios that will take your function execution, extend your function execution, but the function CPU and the memory allocation will affect all of your bills, because it will be affected to all of your functions. So in general, if by default it's CPU of 1 and the 1.7 gigabytes of memory, which in a lot of scenarios is too much, and you can reduce it to like basic one and see if your functions are still executing in like reasonable time. Maybe they will slow down by like 5 milliseconds. Maybe they won't change at all. So it depends on your code that is behind the scenes. But I believe that most of the functions are simple, and we can just reduce that to basic. So why it's reducing your bills? Because Vercel have a calculations that takes the gigabytes per hours, and all of the memory that is allocated to your function calculates to this pattern. So if you choose the smaller CPU and less memory, then this gigabyte per hours is reduced for all of your functions. So one of the places where you can set that is in the Vercel dashboard, but you can also specify that in the code. There's a Vercel.json file where you can specify the same values, but for each function. So you can specify the route for the specific function. In my example, you see that we have a short function, we have a heavy function. So short function is very small one. Let's say that it's just adding some numbers and it doesn't require a lot of memory, and the max duration should be even like 2 seconds. So I don't want this function to be called any time for more than 2 seconds, and I believe that 128 megabytes of memory is enough. I also have a heavy function that I will use a lot of memory, so I allocated more than for the short function, and also I increased the maximum duration to 50 because I believe that it can take that much time. This is not a good pattern. You probably should avoid so long functions, and if you can, you should delegate such functionality somewhere out of Vercel, because there's no point to wasting the resources on some things that can be outsourced. And there is also a third one, which is a default one. So I have specified that for a short function, for a heavy function, and I also have a default that will be used for all of the others. But it should be like 15 or even 10. So yeah, that's how you can quickly reduce your bills using these options. They are all like mentioned in the documentation, but I believe that people are afraid of using those things, but they should. So yeah, that's all of my
Okay, great.
methods.
So thanks, Jakub. So as I understand, you explained several ways to do that. One was more like architecture way, so how to design the whole application and what is the strategy for Next.js development. And two others were, or maybe, yeah, one was about prefetching. It was like small adjustment. And then third one was like updating Vercel configuration.
Yeah.
So thanks for various different methods. And we are having an event. We are having an event next Thursday, 20th of February. So Jakub, what are you going to share on this event?
Yeah, so there were just three of the optimization methods. I will share a few more on this event. I will also mention about how we can outsource the specific Vercel functionalities to other providers, like image optimization, because some of you may use some CMS already, which already have built-in optimization, and maybe it's a cheaper one, so you may want to move it out of Vercel. The same for like CDN or other things that are included in Vercel billing. But yeah, we will also mention about the most of the time we will mention about the other practices that can save you some money. I mean, this prefetching thing was a very small one, but if you multiply like 10 of the small adjustments, then it make the difference.
Okay, so if you're paying for your Vercel and Next.js hosting too much, please join our webinar next Thursday, because we're going to share some practical tips based on our real life experience, and it will be mixed of architecture changes, Vercel configurations, and also using different Vercel plans. So sign up today and see you on Thursday. Thanks, Jakub, for today's video.
Yeah, thank you, Chris, and I hope see you all guys on the event.